Hi, so just a quick video to introduce to you Baumer's new Bearingless incremental encoder, the EB200E. So there you see the sensor head, and you can see I've got a magnetic rotor connected in this little demo unit setup. So this is a 64 pole rotor magnet, and you can see the sensor here itself mounted the correct distance away to be able to pick up on the movement of the rotor itself. So it's got the capability for simple position and speed detection, also via IO-Link, speed monitor function via switching output, and it works on the bearingless magnetic sensing principle. It has the capability to have a maximum resolution of 4096 steps per revolution. Nice and easy and small to use, and available now. So now on to the practical demonstration, and what I plan to do here is with the encoder via the 4-pin connector that we have on the encoder, connect it to our USB-C IO-Link master into our Baumer Software Suite, just to go over the features and information you can get via IO-Link, and also what output states and output information you can get for easy parameterization and easy visualization of the outputs from the encoder itself. So now I've connected the encoder via the M12 connector to our USB-C master and back to our laptop via the USB-C connector. We can now go over to our laptop and see via the Baumer Software Suite to connect the encoder and have a look at the parameters and monitor the encoder output. So now all we do is go to our software suite, find all connect, take a few seconds, it's found the device, just connecting it now. So there you see my computer, the USB-C master that I'm connected to, and now the encoder that is connected to that master, and off we go. And here we are, connected is the encoder, the part name, serial number, port number, etc, etc, and we can see what's going on. And now we can interpolate further what's going on with the encoder, and I can show you some of the features for it. So now that we're into the Baumer Software Suite, we can now go into the parameterization and the monitoring of the encoder itself. So the encoder is connected here. If I then just collapse some of these windows so we can see this a bit better, we have an add-on for the encoder. I'm just wait for that add-on to load, and it allows us to monitor the encoder over time for speed, for steps. So if I start to rotate the encoder here, you can see that the steps per second for speed is being updated live, and also the number of steps it's taken. So I'm turning this encoder clockwise. If I now go anti-clockwise, you'll see that the steps now are decreasing, and also the speed is given in a negative speed. And you can see those results over time here. And if I scroll down here, you can also see the results over time for position in terms of steps moving forward, and then when I was moving it back. And you can see it's steady now here at 17,000 steps. So you're able to go into the settings here for parameterization and enable or disable the speed filter, set the preset value for the number of steps. So if I wanted to say the preset was 1000 steps, for example, and then if I set the preset position to where the encoder currently is, now it says that that is 1000 steps. Or as you'd expect as normal, you can set it to 0. I can move the encoder anywhere I like so, and then preset it again to that specific location. Just to show you with a timing mark, if I put a mark on the rotor here for where it is, I move the encoder, I preset that position to 0, move it back, say again, and you can see where we are. And then again, if I wanted to preset at that same position, I can make that 0. Okay. So also for the speed, I can set it as steps per second or as RPM. So if I change that to RPM now, you can see the measurement here is now done in revolutions per minute. Going in the opposite direction now, what it is there. Okay, let's reset it there. Let's keep it at steps per second. Collapse these back up again, and again the scale settings. So this is dependent on the magnet or rotor that you're using. So the rotor that I'm using has got 64 poles on it. So if I enter which one I have installed, that will give me a good interpolation between the steps per second and also the number of steps taken. So if I'm using a 32 pole rotor, this is where I'd write 32. For the interpolation settings, you can also change them from anything from 1 fold, so 64 to 64, to you see there, to give us 256 steps per second, 512 steps per second, sorry, per second, I say revolution, 4 fold, 1024 revolutions, steps per revolution, 5 fold, 1280 steps per revolution, all the way up to the maximum allowable from this programmable encoder of 4096 steps per revolution, or pulses per revolution. So if I quickly just scroll off my timing mark here, put in a timing mark, say here, and I preset it there, I can now show you that we've set the encoder to 4096 steps per revolution or pulses per revolution. If I now rotate the encoder or the rotor in front of the encoder for a complete revolution, you can see, if I can get it bang on there, you can see I've achieved that complete revolution where the timing mark is, back to the home position, and I've achieved those 4096 steps in that complete one revolution where our timing mark has come back again. And if I go the opposite direction and send it back to 0, you can see that that is one complete opposite revolution there. Oops. But you get the point of getting it back, and the resolution that you can provide in the forward and backwards direction. If I then get it back close to where I think 0 is and preset that and change the factor, say to 4-fold, which is 1024 steps per revolution or pulses per revolution, and I do the same again. Let me just preset it. I've slightly knocked the encoder. I can then now do a complete revolution, and I get that 1024 steps over here. You can also set the temperature range that the encoder works at. What is the minimum maximum temperature? So I can input the values there if required. Okay. You also have the ability to use a dashboard setting on the software, so you can see what the position is, the part number, all this type of thing. Also monitor the speed and direction monitor of the sensor. So if I again move the encoder, if I set a speed, a max or minimum speed, you can see the output goes on and off. Also, as I've got this encoder currently as factory settings, if the motion is in the clockwise direction, the output is good and on. If I move it in the counterclockwise direction, the output goes off or bad. Also, we've got a standstill monitor on as standard from factory settings, so you can see while the encoder's not moving, or sorry, the rotor's not moving in front of the encoder, you can see the output is off. If I'm moving again in the positive or negative direction, so clockwise or counterclockwise, you can see that the output stays on. And you can, via the settings, if I go back to the parameterization here, I can go to the switching channels here. So via IO link, you've got the switching channels, and I can, like I said, put in a window or a single point for the speed in steps per second for when I want the output to go on. If I choose single point, I just type in the value here. If I put in a window, I can then put in the max and minimum, and also change the hysteresis and whether I want the output to be active high or active low here. So if I, for a test, if I'm rotating it fairly fast here, if I say I want the output for speed to come on between 1000 and 1500, or say 1000 to 2000 steps per second, I can do that here. So if I say minimum speed is 1000, oops, sorry, 1, 2, 3, and the max speed is 2000. You can see that the speed monitor switch point is there. If I go over that speed, so if I can go within those limits, you can see the output goes off. If I go too slow, the output comes on. If I go too fast, also the output stays on. If I wish to just go single point mode and say, right, anything over 1000 steps per second activates the output, you can see it is currently off. As soon as I start to rotate in a slow speed, haven't activated the output yet. As soon as I go over 1000 steps per second, you see the output turns on here. Right. I can also parameterize the inputs and outputs. So for the mode, I can have it direct or inverted for the state over time. And also I can activate the function of the encoder to be an IO-Link sensor, or just as the channel A output. Startup state, again, you can select whether it's low or high, and the hold time or test time for the encoder as well. And you can select what you want channel A and output A or output B to do from the encoder. If I also have the opportunity here to save the settings for the encoder so that I can then restore them or load them onto a same type encoder for replacement or other purposes. So you can store settings or upload settings here, or factory reset the encoder if that's what you wish. So if I go back to the encoder here and I go back and collapse all of these, I can see all of the options available to me in one go. I can now monitor the encoder as well as to what's going on, and you can see the outputs going on and off that we have selected and parameterized. You can see here the conditional data of the encoder as well. Device is okay. The device temperature is at 19 degrees C internal. The minimum 8 and the max 20 has been set. It's a fairly new encoder. It's only been working for about an hour and it's done 600 revolution counts. Here you can see again all the standard IODD information that you would expect to see from the sensor itself and from a standard USB master, the vendor ID, vendor name, etc, etc. Here you can update the IODDs, and there is no update available. It's the latest IODD that we're running. It also tells you what the network profile is and what each core of the wire is actually doing. So this encoder can be used as a dual channel encoder. So channel A, or output A, will be the IO link. Here, the black wire. Pin 2 is your B motion, so you can monitor the pulse rate via channel B while still using the IO link over channel A, which will give you the parameters that we've set. So whether you're working clockwise or anti-clockwise, the speed, so direction monitor basically. Also speed monitor, where we set the speed that we want, and also the standstill monitor. So you can monitor all of these over IO link, and you can take motion from channel B if you wish to use it in dual channel. If you solely wish to use it in IO link mode, then of course you can get all of the information as you see it here. So the speed and position, and also these SSC status information. Some great advantages for the EB200E are obviously its compact design, giving you 12mm depth, which means you can easily integrate it into small spaces. It's reliable because of its long-term operation under extreme conditions, dirt, dust and things like that, and resistant to shock and vibration because of the magnetic working principle. It's super easy for commissioning and service and maintenance because of the IO link functions and the capability to plug into Baumer Software Suite for easy parameterization. Because of its wear-free design and secondary data via IO link, it means that you've got the opportunity to have vastly reduced downtime. It's easy to retrofit because of its size and how easy it is to parameterize. And applications can be in all sorts of machines, from textile to machines, drives, AGVs, even wood processing and hoist machines, and of course conveyor belts, tracking movement and things like that. So the sensor is IP67, and the functionality, again, to repeat myself, is magnetic sensing. You can see the small gap between the sensing head and the rotor that we have there. The biggest advantage of all is its cost-effective price. So just to summarize, the EB200E encoder here is a programmable incremental encoder working on magnetic principle. It's easy to use, easy speed feedback, I/O link for cost-effective integration parameterization. You've also got speed monitoring function. We've got solutions for shaft diameters up to 48 mil, and it's got reliable long-term operation where dirt and dust and fibers are present because of that magnetic working principle that we've got there. So Industry 4.0 incremental encoder, small in size, lots of functions available for it, and available now.